Welcome to 7.2. We're talking geometric sequences today, not to be confused with arithmetic sequences from yesterday. They're very similar. They're both sequences. They both follow a rule, but there's a very big difference that we're going to discover right now. Just like yesterday, we're going to start with two sequences in front of you. I want you on your own to pause the video, try to find the rule. Try to find the next three terms in this sequence. Pause and come back when you think you have an answer. Welcome back. 2 to 4. Well, I could try to add like yesterday. Could try to find a constant difference. 4 minus 2 is 2, but 8 minus 4 is 4. I don't have a constant difference. If you notice though, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. I'm multiplying by 2. 16 times 2 is 32. 32 times 2 is 64. 64 times 2 is 128. Now this one, if you notice, it alternates positive, negative, positive, negative. If we take a hint from the first one, we might be multiplying. 5 times what makes 10? 5 times 2. 10 times what makes 20? 10 times 2. What would make it negative? Well, 5 times negative 2 would make negative 10. Negative 10 times negative 2 would make positive 20. So we're multiplying by negative 2. Negative 40 times negative 2. Negative times negative. Enemy of my enemy is my friend. Positive 80. 80 times negative 2. Positive 80 times negative 2 would be negative 160. Negative 160 times negative 2 would be positive 320. Quick think, pair, share. Take a second. Think about what we just observed. Tomorrow we'll pair, we'll share. Pause the video. Come back when you're ready. A geometric sequence. Now, our definition here is going to be very, very similar to yesterday. Geometric sequence is a sequence of numbers in a specific order. Again, we're not looking at just a random set of data. This is a sequence that follows a specific rule. A geometric sequence is a sequence of numbers in a specific order that have a constant ratio. A constant ratio between each term. So yesterday we talked about a constant difference. Today we're talking about a constant ratio between each term. Now ratio, if we think back to our rates and ratios unit, we saw a lot of divisions. We find our ratio by dividing, just like we found our constant difference by subtracting. So we divide at least two pairs of terms, dividing the term to the left from the term to the right. Again, just like subtraction, division has to have an order. If they are all the same, so if all of the ratios are the same, then you have a constant ratio. We have an example here. You could take term 2 divided by term 1, term 3 divided by term 2, term 4 divided by term 3. You're taking two terms that are next to each other, taking the one on the right, divide by the one on the left. Let's try an example together. So I have a sequence here. 2, 4, 8, 16. 4 divided by 2, or you can write as a fraction or a ratio. 4 over 2 simplifies down to 2. You could also just write simply as division and get either a whole number or a decimal, which could happen. 8 divided by 4 gives me a constant ratio of 2. They are the same ratio, so they are a constant ratio. Negative 10. Be careful with those negatives. Negative 10 divided by 5 gives me negative 2. This is why we write out our work. We show ourselves how to type it into the calculator. Negative 40 divided by, or you can even write as a ratio, over 20 simplifies down to, again, negative 2. Our constant ratio is negative 2. When these values get smaller, they can get much smaller, and they'll turn into decimals, not just go negative like we saw with arithmetic sequences. Either they'll turn into decimals, you'll see fractions. So let's try this. 15 over 45. Now you could just simply put that in your calculator and it'll give you a fraction or it'll give you a decimal. This one will come out to be either 1/3 or, as a decimal, 0.3 repeating. I would accept either one. We've talked about the connection between fractions and decimals ad nauseum. Let's look at this final set of terms, 5/3 and 5. Now you could simply plug in your calculator 5/3. You'd want to put it in parentheses, or if you have a fractions button, type it in that way, divided by 5. Or let's look at this, 5/3. We talked about dividing by a fraction. You just multiply. So I keep it, flip it, or sorry, keep it, change it, flip it. I should get 5/3 times 1/5. If I simplify ahead of time, cancel those 5s, I'm going to end up with 1/3 as well. Again, either 1/3 or 0.3 repeating. Either one would work. Either one you could use to find the next term in the sequence. On your own, pause the video, try to find the constant ratios for these three sequences. Remember, show your work just like I did in these examples. If you do not show your work, you cannot receive credit for the U-Try sections. The answer to number 1, or the first sequence here, you should have gotten a constant ratio of 2. Here you should have gotten a constant ratio of -5. Remember, when you see those alternating, positive, negative, you know your constant ratio has to be a negative. That should be a little red flag, a good way to check your work as you're going. The third sequence, the answer should have been, you could have given me either -1/2 if you went the fraction route, or if you went straight to your calculator, which is perfectly fine, you would have gotten -0.5. Remember, you want to check at least 2. If you check 3, that just means you've really proven yourself. Now, to find the specific term, we go ahead and we start by finding the first term in the sequence, which we're given, 5. The fifth term, now in order to find the fifth term, we want to look, what's our constant ratio? 10 divided by 5 gives me 2. 20 divided by 10 gives me 2. So I'm multiplying by 2. So the next term in the sequence would be 40 times 2 to give me 80. So that's the fifth. If I wanted to find the 30th, again, I'd have to keep going. Times 2 gives me 160. That would give me the 6th. Times 2 to get the 7th. Too much work. There's always a better way in math. So I'm going to find the formula, the general formula of a geometric sequence. The nth term, this is your answer. This is what you get when you complete this formula. A, just like with the arithmetic formula, is our first term. Now, we're going to have to use exponents in this case. Okay, so we're using our exponents. R is our constant ratio, which we just talked about finding, or how to find. And then N is the term you're looking for. We just looked for the 5th and 30th terms. That would be either 5 or 30. Let's try an example together. Start by finding the first term. First term is 3. It's given to us. Find our constant ratio. I do -6 divided by 3. Again, show your work so that way you can pre-plan before you type in the calculator. 12 divided by -6. I get -2 again. Oops, that should be -6, sorry. Should get -2 as my constant ratio. Find the 11th term in the sequence. Anytime we use a formula, we take the time to type out the whole formula. We want to make sure that we know exactly which values, which variables we are plugging in for. So I'm going to type out A times R. Now on your calculator, you're going to find a button that looks like a little caret. It looks like that. There we go. to the n minus 1. I'm finding the 11th term minus 1. On page 13 of your booklet, you should have a reference on where to find the buttons on the calculator. We'll talk about that during class tomorrow. So we have our n minus 1, sorry. Now we plug and chug. Let's type this all out. A is 3. It's our first term, 3, times R. R is our constant ratio. Now, if you look back, I did put these in parentheses in the general form on the previous page. There's a reason for that. You'll see in a second. To the n minus 1. N is the term I'm looking for, which is 11, minus 1. Move this over a little bit because I am going to end up having to work on the side here. I just do order of operations. I take care of my exponents first. Now, inside my exponents, there's actually a parenthesis. So 11 minus 1 is 10. So I underline, I evaluate, and I rewrite. Negative 2 to the 10th power. So you can write it this way as well. Now I'm going to take care of my exponents. Negative 2 to the 10th power. Make sure you use the parentheses just like that, because when you type in your calculator, it makes all the difference. If you just type negative 2 to the 10th, it's going to give you a negative answer. But if you type parentheses, negative 2 to the 10th, you're going to end up with a positive answer. So make sure you're using those parentheses. 3 times 1024. Last but not least, multiply that together, we should get 3072 as your final answer. Now, these terms can really get high. We're not just adding, we're multiplying. Or multiplying is repeated addition. So we're doing multiple steps of addition every time we multiply. So our values can get much, much, much higher. We do the exact same thing again. Write out the original general formula. Then we plug, then we chug. So we have A times R to the n minus 1 power. A is 3, negative 2 is R, and I'm trying to find the 6th term. So I'm going to end up doing 6 minus 1. Now we chug. Now it's our order of operations time. I know that 6 minus 1 becomes 5. Take care of my parentheses first. So 3 times negative 2 to the 5th power. Take care of your exponents. Negative 2 to the 5th power becomes negative 32. Again, watch those parentheses. And I am left with 3 times negative 32. Remember, negative 2 to the 5th became negative 32. You should end up with negative 96. You can even double check it if you really wanted to. Negative 24 is the 4th term. Negative 24 times 2 would give me positive 48. Positive 48 times negative 2 would give me negative 96. So that is the 6th term. I was correct. On your own, pause the video, go ahead and try these examples. Remember, in order to receive credit, you must show your work. First term is negative 4. Constant ratio is negative 5. The 6th term in the sequence should have come out to be 12,500. Again, you can end up with particularly large terms. Even bigger, the 8th term is 312,500. We just covered geometric sequences, both finding the constant ratio and finding any given value in the sequence. On your own, rate how well we hit our target. If we did not, please let's discuss in class tomorrow, and I will see you